So look, welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment below. Make sure you share this video with at least one other person and have them share with at least one other person. Or if you want to, share it with two people, have them share it with two people, so on and so forth. I just want to get the message out. All right. So now look, what we're about to do now is we're about to find the LCM, right? The LCM. Now, what does LCM stand for? It stands for least common multiple. Least common multiple. All right. Meaning that's the smallest number that these numbers have in common that they all can meet up at or they all can multiply into. That they multiply into. Please do not confuse a multiple with a factor. That is a very common error. Do not confuse multiples with factors. Multiples are numbers that are a multiple is a number that numbers can multiply into. A factor is a number that can multiply into other numbers. All right. Let me break it down with an example because what I just said sounded confusing. It sounded confusing to me when I was saying it. Think about the number 30. All right. So 60 is a multiple of 30. 60 is a multiple of 30. 60 is not a factor of 30. Why is it a multiple of 30? Because 30 times 2 equals 60. 30 times 2 will get you 60. All right. 60 is a multiple. However, 5 is a factor of 30 because 5 times 6, and 6 is also a factor of 30 because 5 times 6 equals 30. So the factors are the numbers that get multiplied to make another number. The multiple is the number that gets made. The multiple is the number that gets made, right? 30. Now here's another thing to keep in mind. All right. Don't let it confuse you. Every number has itself as both a factor and a multiple. Every number, I'm gonna say it again. I'm gonna say it a little slower. Every number has itself for both a factor and a multiple. Let's go back to the 30 example. 30 times 1 equals 30. That means that 30 is a multiple of 30 because 30 would be the product if you do 30 times 1. However, 30 is also a factor of 30 because you did 30 times 1 to get 30. So keep that in mind too, right? It's not that confusing, right? Don't let it confuse you. Just memorize that and you'll see the examples, right? Like 6. 6 times 1 is 6. So 6 is a factor because you did 6 times 1. And 6 is also a multiple because 6 times 1 equals what? It equals 6. That's all you got to know. All right. So now let's get into this. Let's find the LCM, least common multiple. Now, there's many ways to find the LCM. All right. When the numbers get kind of large, it gets difficult to kind of eyeball the numbers and to just like, okay, take the bigger number and use a typical method, which is taking the biggest number out of the group and multiplying it by 1 and then checking to see if that number if that new product is a factor, is a multiple of the other numbers. And if it's not, then you go down the line. You do the biggest number times 2. You repeat the process, rinse and repeat, right? What the biggest number times 3 until you find out what it is. But that could be a little tedious, right? So one of the methods that we use often is called prime factorization. Prime factorization. Prime factorization. Where you basically do like the factor trees and you factor out each of the numbers, which is what we're about to do now. We're about to use prime factorization method. All right, so let's do the prime factorization of each of these numbers. So first we're going to do 30. All right, so I'm going to write 30 and I do the trees, right? These are like, it's like number bonds, right? Like number bonds that like the kindergartners and the first and second graders might do, right? We basically do a number bond. So like if you're a parent watching this and you got a child in first grade or kindergarten, you be wondering like, why we got to do number bonds? Because it's preparing them for this. They're going to need to understand and develop number sense. They're going to need to be able to figure out what an LCM is. The LCM is of a bunch of different numbers. So if they was in first grade already doing that, by the time they get to fourth and fifth grade and it's time to do prime factorization, right? They already going to be familiar with that process. So everything is done for a reason, right? Just because we ain't learning things that way in first grade 40, 50 years ago or whatever, it don't mean that it's stupid. It don't mean that it's dumb. It don't mean that it's useless. Now, hopefully it's being taught correctly and properly. And hopefully parents are being told what the method is or what the logic is behind it, but just understand there's a reason for all of it. All right, so 30. I want to think of two factors of 30. Any two factors, don't matter what they are. So I'm going to say 3 times 10. So I'm going to put a 3 right here. I'm going to put a 10 right here. Now, the 3, I can't do nothing with the 3. That's a prime number, which is cool, right? But the 10, I could break down. I could further decompose. That's the technical term we use. So I'm going to break the 10 down into 2 times 5. Now I am finished because this is the prime factorization because I have all prime numbers at the ends of my branches. I got a 3, a 2, and a 5. 3, 2, and 5. That means that the prime factorization of 30 is 3 times 2 times 5. All right. Now we go to 70. We're going to do the same thing. We're going to go to 70. Break 70 down. So I break 70 down. I could do 7 times 10. I feel like being different though. I'm going to do 14 times 5. See, I know my 14 facts, some of them from memory. I'm going to do 14 times 5. All right. So 14 times 5. I'm going to write 14 right here. I'm going to write 5 right here. Now 5 is a prime number. So I'm going to leave the 5 alone. I don't need to decompose 5 anymore. But 14 is composite. When we're doing this method, all composite numbers get broken down. So we need to understand the difference between a prime number and a composite number. Prime numbers only have 2 factors. Prime numbers only got 2 factors. Composite numbers have more than 2 factors. They could have 3 factors, could have 8 factors, could have 20 factors. But prime numbers have exactly 2 factors, one and their self, one and their self, one and their self. That's it, 2 factors. Composite numbers have more than that. So 14 is a composite number. Let's break him down. So break him down to 7 times 2. Now we are finished because 7 is a prime number, 2 is a prime number, 5 is a prime number. We have all prime numbers at the ends of our branches. So we got 7 times 2 times 5. All right, so that's done. Now we're about to do 105. Let's go over here to 105, break 105 down. Now, I know that 5 is a factor of 105 because I know by the rule that any number that has a 5 in the ones place, or we say has ends in 5, has 5 for a factor. So let's do this. Let's say 5 times what? Now I know that 5 times 20 is 100. Now this is where number sense comes into play. And what do they call it? Automaticity, right? And multiplication facts, right? Because I know that 5 times 20 is 100, right? Or a bean, 105 is just 5 more. So that's 1 more 5. So that means that 5 times 21 must be 105. See what I just did there? See, a lot of that's because I have good number sense. And a lot of the things that are being taught now that we label as new math and some of us think are stupid and unnecessary, right? Actually serve to develop fluency in your children. So that way when they see a number like 105, they're like, you know what? I know that 5 can go into 120 times. Boom. So if I know that, I know 105 is just one more group of 5s. So that means that 5 must go into 105 21 times because it's just one more group of 5s, right? A lot of that stuff comes from a lot of stuff that is being taught now that we think is dumb, but it's not really dumb, right? It's just different, right? And it's developing the number sense in our children. And these might be methods that we weren't exposed to when we were in elementary school, right? So don't hate on it, embrace it, learn it, right? It's beneficial for all of us. So now I got a 5. The 5 is prime. We can't do nothing with the 5. We can't break the 5 down no more. 21 is composite though. We could break the 21 down. Know your multiplication facts. Know that 21 can be broken down into 7 and 3. All right? 7 and 3. 7 and 3. Now, 5, 7, and 3, right? These are all prime numbers. So now, with the prime factorization method, after that, one of the ways we do this, right, is it's a few ways to do this, right? So what we can do is this. We list each of these numbers like in a table format. So I'm going to write 30, and then I'm going to write the prime factorization of 30. 3 times 2 times 5. So I write 3 times 2 times 5. And then I'm going to write 70. Then I'm going to write the prime factorization of 70, which is 7 times 2 times 5. But I want to line up alike numbers vertically, right? So I'm not going to put the 7 under the 3 because that's not a 7. That's a 3, right? I'm going to put this 2 under this 2, and I'm going to put this 5 under this 5. So I'm going to do this. I'm going to do 2 times 5, and then where am I going to put this 7 at, though? Oh, and put it out here by itself, underneath of nothing, right? So what you want to have when we use this method, this particular method with the prime factorization, and then the table after that, we want all of the same numbers lined up vertically. All of the same numbers lined up vertically. 3s over 3s, 2s over 2s, 5s over 5s, 7s by themselves, or 7s over 7s, or 7s under 7s. All right, and then we go to the 105. We're going to do the prime factorization of 105. So I got 5 times 7 times 3. All right, so we got the 3 is going to go underneath of this 3. And then the 7 is going to go underneath of that 7. And then the 5 is going to go underneath of that 5. And then I draw a line like this. And I got my 30 prime factorization, 70 prime factorization, 105 prime factorization. And then underneath of the line is going to be the LCM. And I basically just bring down one of each of these digits from each column. So if I got 2 3s, I bring down one of the 3s. I got 2 2s, I bring down one of the 2s. I got 3 5s, so I bring down one of the 5s. And so when that happens, this also lets you know, even though right now we're only looking for the LCM, this lets you know that 5 is the greatest common factor. Whenever you have a column that has all 3 spaces filled in, because that means 30 has a factor of 5, 70 has a factor of 5, and 105 has a factor of 5. They all 3 numbers got 5 as a factor. So that means 5 is the GCF, the greatest common factor. All right. And then 7, we take one of them. And then we're going to multiply these numbers out, and then the product will be the LCM. The product will be the LCM. So we got 3 times 2, 6, 6 times 5, 30, 30 times 7, 210. How do I know that? 30 times 7, I can pretend that 0 in the 30 is not even there. And I can do 3 times 7. 3 times 7 is 21. And then I can reattach the 0 to the 21. 21 with a 0 attached to it is 210. 210 is our LCM. 210 is our LCM. So this is the method for finding the LCM called prime factorization. Using prime factorization. Now there's another way to find the LCM after you do the prime factorization that does not require setting up this table. Even though the table is cool, it's a good way to like organize your data, organize your information, and find the LCM. This is cool, but there's another way to do this. Yeah. I think it's coming back to me now. So I think what you got to do is, okay, this is what you do, right? So what you do is this. So, okay, 3 times 2 times 5, 2 times 5 times 7, 3 times 5 times 7. So what happens is you basically you take each prime factor and you say, okay, 30 has a 3, 70 don't got no 3s, 105 got 1 3. So you say, okay, the maximum amount of 3s that you see, because you do this too, like when you get into algebra, like algebra 1, algebra 2, and you find the least common multiple of algebraic expressions, right? Like x plus 5 or like x squared plus 3x minus 2. Like if you had to find an LCM of expressions like that, you would kind of do a similar thing. I got other videos about that too. But you said this has a 3 one time, this has a 3 0 times, this has a 3 one time. What is the maximum amount of times you see a 3 one time? So that means 3 is going to be part of is going to be one of the numbers that leads you to your LCM. So it's kind of like this. I mean, it's basically the same thing that we did here, but it's kind of like, so let's do this. So this has 1 3, this has 0 3s, this has 1 3. So therefore 3 is going to be one of the numbers we use to find our LCM. So we cross the 3 out because we use them. Then this has 1 2, this has 1 2, this has 0 2s. The maximum amount of 2s we saw was 1. So that's a 2. Boom. And then, so cross them out. And then this has a 5, this has a 5, this has a 5. They all got 1 5. What's the maximum amount of 5s we saw in each number, in each prime factorization? 1. So therefore, we're going to use 5 one time. And then, so cross the 5s out, cross the 5s out. And then this has 1 7, this has 1 7, this has 0 7s. What's the maximum amount of 7s we saw? 1. So then we do what we ended up doing down here. 3 times 2 times 5 times 7. So you see how I asked those questions? Like, what's the maximum amount of this number that you see in this prime factorization or in this prime factor, or out of all 3 prime factorizations? What's the max? We did the same thing because we still ended up with 3, 2, 5, and 7 down here, and we had to multiply them together to get 210, right? But instead of having to think about that, this table just enables us to just have the work showing. But actually, like what I just described is actually probably better of a method because, well, at least if you're thinking about that when you're using the table is really organized though. I dig the table too. The table is cool, but just understand like why it's set up like that, because you're looking for the maximum amount of times that that number shows up in the different prime factorizations of each of these original numbers, 30, 70, and 105. You know what I'm saying? But yeah, go get some practice with this and stay locked in. I'll see you on the next video.